So my first question here says, how many centimeters are in 1 foot? So again, recall our equal group structures. So if I do number of inches times centimeters per inch, that will give me total centimeters. So in a foot, I know there's 12 inches. So I can go 12 inches times 2.54 centimeters per foot. And then again, I could use, now, in this course in general, we do not use calculators. On exams, I will give you numbers that you do not need calculators for. However, this is probably the one section in the whole book where calculators can save us some time and be worthwhile. So you can go, 2.54 times 12. And I am actually just turning on my calculator right now. 2.54 times 12. And I get 30.48 centimeters, right? Inches times centimeters per inch should equal total centimeters. So there'd be 30.48 centimeters per foot, right? If I wanted to then answer this thing clearly. I could also say how many inches are in a meter. Now again, using this conversion and thinking of equal groups, I can multiply centimeters by inches per centimeter to come up with total inches. Now, I know there's 100 centimeters in a meter, so I just need to find out the inches per centimeter. But what we have here is centimeters per inch. If I want inches per centimeter, I need this to equal 1 centimeter. So if I divide both sides by 2.54 and 2.54, I actually get 1 over 2.54 inches is equal to 1 centimeter. And again, you could come up with a calculator to change that into just a single decimal. But I get number of centimeters times the inches per centimeter. And now when I multiply, you multiply the numerators and the denominators, so I get 100 over 2.54 total inches, which if you do 100 divided by 2.54 on your calculator, this gives us about 39.37 inches. So again, all equal group structures. All right, now here's another question. It says, how many kilometers are in a mile? It's a question that I often wondered, so let's just scribble this out really quick. Now, I remember seeing in races, oftentimes there's races that say it's like a 5K race, but that's the same thing. They always say 5K or 3.1 miles, but it's not exact. That's just an approximation. If I want to know the number of kilometers in a mile, well, if I divide both sides by 3.1 and 3.1, I will get 1 mile equals, now let's see, 5 divided by 3.1 on my calculator. This thing says 1.6129 ... kilometers. Now, this is not equal, so I'm going to get rid of the equal and make it an approximately equal. That's the squiggly lines, right? Approximately equal. And so when you do this for this, we get this thing. And it's actually not exactly correct, so we're going to see what it should be. So if I want to go between kilometers and miles, the thing we have that connects the standard US system to the metric system is the inch to centimeter conversion. So what I'm going to have to do is work through this. I'm going to have to go from kilometers to centimeters to inches and then inches out to miles, or vice versa, miles to inches to centimeters to kilometers. So however we go back and forth, we got to go through the inch centimeter connection, which is right here. So 1 mile, 5,280 feet. If I go feet times inches per foot, I will get inches. So 5,280 feet times 12 inches per foot, used my calculator, is 63,360 inches. Now, if I go inches times centimeters per inch, I will get centimeters. So the total number of inches in a mile times the centimeters per inch will equal the total centimeters per mile. And now we start working the other direction. If I know the total centimeters per mile, I need to go centimeters times meters per centimeter to give me meters. Well, I know that there's 100 centimeters in a meter, but what I need is the meters per centimeter, so I'd have to divide both of these by 100, and I would get 1 centimeter is equal to 1/100th of a meter. So now I can go total number of centimeters in a mile times meters per centimeter equals the total number of meters in a mile Please take note, this is also something we've talked about. When you multiply by 1 over 100 or divide by 100, it just moves the decimal place back 2 places, but other than that, the numbers should look basically the same. So again, this should now be in meters, and we're trying to get to kilometers. So if I do meters times kilometers per meter, that will equal kilometers. And so I've already got the meters, and I need to multiply by kilometers per meter, but I know that there's 1,000 meters in a kilometer, but I need kilometers per meter, so that would say that 1 meter is equal to 1 over 1,000 kilometers. So meters times kilometers per meter equals kilometers. And so we can then say 1.609344 kilometers is equal to 1 mile. And that is slightly different from the quick abbreviation we had up here. All right. So this stuff we're actually doing here, some people call it, unit conversion is what I called it. It's also oftentimes referred to as dimension analysis because you don't necessarily need to convert from one length to another. You can convert between dimensions. You can convert between volumes and weights and all sorts of stuff as long as you know how they are linked in a given context. So there's an example here. They say, suppose that a German car is 5.1 meters long. And then the question says, how long is this car in feet? And so again, they're going to go through the inch-centimeter conversion. So they're going to go from meters to centimeters, centimeters to inches, and then inches out to feet, because these are the two that we can link. Now, what I did above is I did this step by step. And for each conversion from miles to feet, feet to inches, inches to centimeters, centimeters to meters, meters to kilometers, I made a new equation, but really you can put this in one long string of equations. And so what they have is 5.1 meters. But then they multiplied that by centimeters per meter. Sorry, that got too faded out. But when you multiply meters by centimeters per meter, this automatically becomes centimeters. And now this is centimeters times inches per centimeter. And when you multiply centimeters times inches per centimeter, that gives you inches. When you multiply inches times foot per inch, this automatically gives you feet. And so it's just putting together a string of equal groups problems, right? Multiply those, we now have centimeters. Multiply these, we now have inches. Multiply these, we now have feet. And so it's putting all of those conversions into one sentence. All right, next page does an example in a similar manner. They say, suppose we want to convert 25 meters to yards. And again, we're going to go through the same inch-centimeter conversion. So 25 meters to yards. All right, so if we start by 25, I'll start down here, 25 meters. You multiply it by centimeters per meter, that's now centimeters. You multiply centimeters by inches per centimeter, this is all now inches. We multiply inches by feet per inch, that means this is all now feet from here to here. And then you multiply feet times yards per feet, and then that would give us the final answer in yards. So that's one of the methods. The other method is to simply lay the stuff out in a table, because we know when we multiply fractions, we multiply numerators and we multiply denominators. And so the first one starts with our 25 meters, and then it is centimeters per meter, inches per centimeter, foot per inches, yards per feet. And what you would end up doing is you cross off your units like so, and we would be left with the final units of yards. And all you do is you multiply everything on the top, you multiply everything on the bottom, and then you divide the top by the bottom, right? That's all of our knowledge from fractions. We multiply numerators and denominators. And so all this does up here is it's a table method to sort of simulate and make easier everything that was happening down here. So one of the things I'm going to ask you to do for this homework is this question right here. It says, use dimensional analysis to convert 1 mile to kilometers. Now, we already converted 1 mile to kilometers up here, but I did not do it with dimensional analysis. Well, I did it in multiple different steps, right? Step 1, step 2, step 3. This thing is saying, can you take all that work up there and combine it into a single long equation like this to come up with the answer? So there'll be that and a little bit more. And that's it for this video.